Why is ASP?
Let's start with question 4 because I think question 4 is probably the more interesting one.
Yeah.
Okay. So
why all the way that difficult like this? They're actually tricking us, bro.
S is a
Dude, I
subset.
could have at least got points on 5 if it was 2. If they put 5 where 2 was, then I would have.
Not necessarily distinct.
Oh god, these people know which one's harder and which one's not. There's no way they think Q4 is easier than Q5.
Okay.
But why would they put
A,
it
B in S.
I think they're just dumb.
Why would you put it there?
Yeah.
It's a trivial way of ceiling.
Oh, was it and or
Ceiling,
for now?
ceiling.
That's yeah.
Okay.
Oh, if it's orders, that's so much harder.
Yeah.
Anyway,
Oh, yeah.
All would be just
all would be so terrible.
It's still pretty good.
Find all S.
But we all wait before we came out.
Okay, so supposedly can S be the empty set?
No, wait.
Okay.
Non-empty.
Non-empty.
Theoretically, it could be.
It can just be one.
Okay.
It can be 1.
So firstly, we see if A is in S, since it's not necessarily distinct, it means that A squared is in S.
Yo, if they do what you call it, if they give
And
It
question,
means A to the N.
if they give a derivation question, I will be
if
so happy.
A to the K and A is in S.
Because I know complex math. And that's what we do.
Oh yes, that's all.
Yeah, the geometry problems, it's called computational geometry, and apparently all the people hate it.
What's ISC?
Because I think it's literally Olympiad geometry problem, but given in a computational form.
Okay, so so junior level person concludes from here that S must be an infinite set. So is the junior person correct?
Yeah.
No.
Yeah.
Leo is a junior person.
Well, if it's not 1, it doesn't have to be infinite.
Oh wait, if it's not one.
If it's not 1, it's infinite.
So it means
Wait, has the juice been completed?
if A is not equal to 1, it means that S is infinite.
Yes, S is infinite.
And if otherwise, if S is equal to just 1,
Not really.
so S equal to just 1 works.
Well, that's for me.
In the exam, can you just write it clearly works?
Wait, look at this. Clearly a parallel algorithm. This entire section is just.
Now we'll do the second working case. So can S equal all of the positive integers?
Probably.
So yes.
But yeah, hell yeah.
Not just probably.
Because yeah.
Yes.
So now, what if S is not? So
If
now,
S is a powers of a number.
if S is equal to, oh wait, we need 1 as well. Wait. Oh yeah. So is 1 always in? Is 1 always in S?
Yes, 100%.
This one was in S.
It's kind of
rhetorical
questions. Yeah. Is 1 always in S?
We have just
Yes. Wow, he is smart. That is very smart. Intelligent. Insanely.
I just want to see
Oh
what
damn!
definition is.
Even I figured that.
Okay.
Then it must be
So
different.
now does S equal work? Does this
Yes.
work?
Yes. Yes. Yes.
So let's just make it. I don't know. You can make A equals 1 as well, but just to make it less silly, or just make A at least 2.
Yeah.
Yes.
That's because
This seems to work.
It indeed works.
What does Y say?
AK over AL.
so this is either equal to 1
1 or something.
or minus 1.
Well, it's yes.
Yeah. That's right.
So
That's
this is
correct.
K is less than L.
Let me test the.
So now the part everyone is waiting for.
So it's theory that only Yasuru knows.
Suppose
What the
That's-
hell is this?
suppose that
Test this one.
let's suppose that x and x
Oh, it's making
equals.
cordial. Like the cordial is-
Suppose x and y are in S,
Yeah.
and where x and y are not powers,
Of each other.
It doesn't.
not powers of another number.
I'll go back.
Another.
Is this the
Another is it.
Actually, it doesn't have to be in S. Wait, so x and y are not powers of another set. Not a set. So this is saying x. Yep. So x is not equal to y. X and y in S where x and y are not powers of another set.
Suppose x is not equal to y.
Oh, wait, actually, I'll do. Actually, I'll make it a bit better. Wait, wait. Actually, I'm just going to change it. Let's say x is. I'll just make x the smallest number. Suppose y equals not power of x.
Are you sure? Orange is audio.
Okay,
It isn't orange.
so y is not a power of
The
x.
suspicious orange. Yeah.
So y is in S.
The oranges do look suspicious.
Also, so y has to be greater than x.
X is small.
So we know that all. So
Wait,
all.
suppose x is smallest in S where x is not 1, right?
Yeah, not one.
Oh yeah, wait. Yeah, okay. See, not one.
Not one.
So in this we are supposing s is not equal to just one. So proving
I don't know.
if x is the smallest number in S that's not one, suppose y is not a power of x. So proving that there can't exist a y that is not a power of x that is in S.
Unless it's all the integers.
Oh yeah, unless that, yeah. So all x to the m and y to the n are in S. So now we look at the interesting part. We look at ceiling of x to the m over y to the n, and try to make equal to any
To whatever you want.
integer k.
And here's why Yasuru uses his
This
theory.
is the hardest part.
Yeah, this is the part. Yeah.
Okay. So this is equivalent to x to the m, y to the n. It's less than or equal to k less than. No wait.
Oh my god, I did this exactly like
Oh, it's less than k.
Oh wait, hold on. I just had a revelation.
So now
Wait,
we're
I
going
have
to
a
use.
basic- hold on.
So now we're going to use a
I
school
don't know.
maths technique.
Use the log.
Wait, what? Doesn't that make
Bro, I did this exact thing in my working. What the hell?
the log?
Yeah, the log. Yeah, I did this exact thing.
Yes, a school math technique.
That's the other kind of a log.
Okay, so
With
now.
Yeah, but then this
So
was.
now there's a slight pitfall or a slight thing to make sure of. So the duration. Actually, no, that's no, we'll get that to later. Okay. Okay.
Punchlines.
What's the Dirichlet thing?
So firstly, the question is
I don't even know what it is.
log.
I was
log
thinking that
XY
it should be true, but I didn't know if it was true.
Okay, here's a hard question: is log xy rational or irrational?
Irrational.
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 It isn't irrational.
No, it's rational.
What? Isn't it irrational?
Wait, it might not be either.
Okay.
Wait.
So
Either rational or
It can't be rational. Because it's a fraction.
it's complex.
No, but then no.
It's
One of them.
complex. Complex
Because it's a fraction.
definition.
That means-
like 5 on 2 or something.
Oh, and they
so it's saying that
Oh, you mean it might not be defined?
y to the power p over
No,
q.
no, like it can be Sometimes it's irrational, sometimes it's irrational.
Y to the power P over Q is equal to X.
Like that.
Point-wise.
Oh, but there's a slight problem.
Wait a minute, but then there must
So
exist.
Y is not a power of X, but
Then you can
does
use
this? How does this
GCD
match up with
stuff.
this?
Well, I mean,
To make
possible.
it
That's like some power of Y.
Yeah, it's like
Like,
So you have to
then
actually.
you take GCD of
yeah,
P and
you'll have to
Q,
take GCD.
and then something.
Or GCD
Yeah.
of X and
Oh
Y.
yeah,
Makes it
so
difficult to change that.
GCD of P and Q equals 1. So if you immediately said this is irrational, then it's not not.
It's not.
I mean, as in I said, if you immediately said it's irrational just from this, if you immediately said it's irrational just from this, it's sadly you may be losing marks. So
Well, I didn't even get any of this. So
Yeah.
I am not to be worried.
I don't even have.
so this is actually a PST question.
Oh, what?
They're saying the question says if y to the p equals x to the q, prove that one of y and x is a power of the other.
Oh, what?
So that's actually a PST question.
Wait, what?
Wait,
Why
actually,
not?
what?
Why?
Yeah,
Wait,
it's-
what? Huh? That's not
exactly the same ratio. So,
Like, that's not true.
wait.
So we're saying yeah,
Oh, wait, yeah.
if y to the p equals x to the q, then one of the numbers is a power of the other.
Actually, yeah, I can believe that.
I don't think that's
Practically
true.
eight,
What is that? That's
four,
not even.
Let's do some small
So we need
but if it's 4,
Wait, that doesn't sound true. What the heck?
I know, but like.
Ah, no, that is.
I know, but like.
Oh wait, they're
I believe
primes.
this, I
They
believe
go
this.
prime. Wait.
Oh, yeah, because the code.
Wait, that.
Wait, is X and Y co-prime?
No, P and Q are code.
okay, so
Wait.
I just make the prime factors. I just make them all s's. So then some of the numbers can be. These are just the shared prime factors, both of them. So some of the alphas or betas can be 0. And now,
Oh shit.
Yeah.
so now y to the p. Oh no, wait.
What the? Oh, no.
Let's see.
Bruh.
So y to the p is the product of the p.
Oh, P alpha 1. P alpha 1 equals P beta 1.
Okay.
Pi of beta iq. So what can you conclude?
Beta I on alpha I equals P on Q.
Yeah.
So what is beta I divisible by?
P. Where P and alpha 1.
Because P and Q are co-primes. So oh yeah, P is not prime also. So it's just, okay. So P is not P and Q are just co-primes. So Q is a factor of alpha I. P is a factor of beta I.
I'm so confused.
Okay,
What?
let's make
I don't think this is true.
alpha I. Let's say alpha I is equal to Q gamma I.
Yeah, sure. Oh.
So alpha is Q gamma I. Yep. That means beta I has to be P gamma I.
They are equal.
Oh.
So now y is equal to
No, that means Y and X are both powers of.
oh yeah, I think I mean yeah, I meant yeah, sorry, I didn't mean x and y's power. Yeah, I mixed up. I meant x and y is the power of something else. Yeah, x and y is the power of something else. Yeah, that's what I meant. So P1.
Okay. You get that
So-
irrational. Wait, does duration function? Oh wait, yeah, it's mainly for rational. It's equal to the gamma I.
Wow, you can approximate rationals with rationals.
You'll get something like this, and then x is equal to
Yeah, I just forgot.
That's crazy.
so x is equal to P1.
You can approximate rationals with rationals.
Oh. What? Yeah, P
Oh,
alpha
yeah.
1.
Irrationals are even more dense than irrationals.
Okay, so what do you think we have concluded, Leo?
I
What?
haven't concluded anything.
So we
The
concluded-
powers are the same.
Yeah, x and y are the powers of the same number.
Yeah.
Oh,
Yeah.
right, yeah, okay.
Yeah, I think I mixed it up. I accidentally said x and y is power of algebra. Yeah,
Oh, wow.
I actually meant X and Y are powers of the same number. So
Yes.
Clearly, that's true.
I'm not sure if this might be quotable, but since it's a PST question, it means it might not be quotable.
Yes.
Quote the PST question.
Yeah, just quote another question. It's
Well, as in, if you didn't know the source, then yeah.
It's a bit,
Sauce. Saucy young
I wish
boy.
just like go back
Where's
to
the
memory. I
source?
scroll through like everything.
So
Just like all the sources.
yes.
So y is equal to c to the q
Bro,
and
how
x
much
is equal to
memory
c
we
to the
have?
p.
Like photographic memory.
You actually be a genius.
No, but imagine the data overload every moment, alright?
Yeah.
Like every
So-
single frame.
I wish
Don't look at
I wish
me.
I'd selected.
So-
Okay, so what's the problem?
Can you select
So what's the
after?
problem with x and y being
Not at the
powers of
time.
some c?
You can select. You can select
That's
what
just
you want to
an
remember.
Is that a contradiction to what we had?
Yeah. So we said y is not a power of x. So can
I mean, it's effectively
yeah.
the same thing, because like you can generate the whole thing.
Yeah. So if y is x equals c to the p.
I feel like we're stalling for the interesting parts. Okay. Yeah. Okay. Yeah. Whatever.
Okay, yeah.
Okay.
Let's get to the lyricism.
Okay, yeah.
Okay, Jerusalem time.
The Rocher.
Okay, wait.
Yes.
We need to.
I'm panicking.
Yes, let's keep going.
So
What the?
so x to the t. So y is a power of x. Then x to the t is what c to the pt, which is c to the q. So pt is q.
What the?
Bro, what is
Ah.
I mean, you need to write this down in your
Oh,
proof.
there's an equal sign, not a minus sign.
You need to write this in your proof.
Wait, so what is it saying? It's saying like if two things,
So we're saying x to the t must be
one
equal.
thing is irrational compared to another thing, then they can approximate anything. I don't know. Wait, is that what's saying?
What are we doing?
Good question.
Good
Oh,
question.
you're just getting bombarded with questions like, yeah, like to distract you from
Okay,
wondering
how about this?
greater
I just
purpose.
rewrite it. I just say y and x are not the powers of.
The same thing.
Of
No,
the
wait.
same thing.
Wait.
Yeah, just suppose y and x are both not powers of the same thing. Yeah. But
Oh, but you have to already fix.
that's some general.
You have to already fix your number.
Lost of which of
Oh, because this is the reason. Wait.
With
Look at
log.
this.
This is the log.
Oh, here's the actual thing. Wait. So y. So we know y is greater than x. So q is greater than p. But now you can do y over x.
Whoa. That's
Oh,
crazy.
So then you get an even smaller. Yeah.
Just keep using it. This is the crop hand. They won't.
Yeah. So eventually you go down to c.
Oh, you get C, yeah. You're the
Yeah,
Duke level.
yeah. Yeah.
Yeah, because p and q are. Yeah, p and q are.
I was trying to apply that.
12K.
Wait, what? You did for
C
integer.
The
C
p
is
is
an integer. Wait,
Eventually-
why are we doing this? No, but C is not in S. You don't know C is in S.
You can get C's in there, but
Oh, is that what you're trying? Oh, is that what you're trying to show?
So trying to show that p.
Sometimes you tell us what you're trying to show. It does help understand.
So that means eventually c will be in s. Because yeah, so c to the p and c to the q means c to the q minus p, and continuing reducing.
C to the AQ minus BP.
Still ignoring the bazoo.
But zoo, yeah, C to the AQ minus BP is in.
Oh yeah, wait.
Oh wait, bazoo.
Zoo, yeah.
Wait, I just.
You learned this in Tuesday, mate.
Wait,
We did this in Tuesday. Bazoo.
Wait, how do you do bazoo on like irrational?
Irrational.
no, P.
So this is bad
This
because
is rational.
P and Q
Q
is
integers.
this is bad because p has to be 1. Because x is the smallest.
Oh right, yeah, of
So
course.
so x has to be 1 because c is in s.
Oh right, yeah.
So that's the reason it's a contradiction now. So that means y actually is a power of x. So that's why.
Wait, isn't this like
Genius.
just Euclidean algorithm?
See, you were
Yeah,
urging me to
that's
skip
what
this
bazoo
part
is.
when it's actually.
It's just Euclidean algorithm.
Alright, now down to Rushley.
So
Now give us to Rushley.
So it's irrational. Oh, you've just proved it as irrational.
Yeah.
Are you sure LMY
Okay,
is
now
greater
that we
than
use
So
zero?
we have just proved that it's irrational.
You use derivative.
Yes, we have just proved it's
With y equals 2.
As in, like, we've only proved that it's irrational.
yes.
Okay,
With y
so
equals 2,
y equals 2.
then when you be divided by a negative.
Greatest fans.
can I
obviously have
write in the
greatest
exam?
friends.
I'm sure there's something.
Hang on a
some
second.
famous
That's a bit weird.
Oh wait, no, y
mathematical
can't equal
theorem
2 because x
that
has to
states that this works.
Okay, no, it's
But
all
I don't know what.
I know, like if y equals 2, ln of 2 is less than 0.
Yeah.
But like, but it doesn't matter, So you have to flip sides, but like, even then it wouldn't matter because y can't equal 2. Because like x has if y equals 2, then what? X has to be the smallest, right? That's not 1. I didn't take it, it doesn't matter.
No, that's a good save. I didn't realize that.
Good save, that's a good save.
So y
So we're
is
trying to show this brown stuff, yeah?
Yes.
y is greater than 2.
Wait a second. What's going on?
What is everything as I sound salty?
Okay,
You got a hater in the audience.
so now this is we're saying.
No, even if it's.
So this is kind of equivalent.
It's not negative, is it?
No,
It
that-
literally has
it's
it
like
right.
2.7.
So now,
Oh wait, yeah, it's a fraction. Yeah,
No, yeah.
yeah, no, it's all good. Doesn't
No,
matter.
it's all good.
so,
No, you
so now,
don't need
Yeah,
so this looks a bit weird, but the important thing is we can make n. N can be any number we want,
Yeah.
which means
Either or.
the only thing that matters is the fractional part.
What?
What?
So
So-
we're,
Oh right, yeah. It's like the fractional part of that.
are we assuming we have this K? We don't have K.
So,
yes,
so
this
saying
is
given a fixed k, so given k, there exists m and n.
Okay, we're trying to show that no matter what the K is, there exists M and N
Oh.
such that the original x log x over y
Oh, yes.
Oh yes, I see.
is between those things. Yeah.
So now, what do you know about log x over log y?
Log x space y. Interface theorem.
No.
That is not the same.
Interface.
In the bed.
So what do you know about this?
That's
Nothing. Absolutely nothing.
That
Wait,
is a number.
wait, isn't it less than 1? Oh wait,
It's
irrational. Oh right, yeah.
Oh yes, this number
Yeah,
is less than 1.
We've agreed with you.
Oh, I see the Dirichlet. Wait, can you come? Wait, how
What
do you
is
do
Dirichlet?
Dirichlet?
I'm seeing.
How do you
So-
prove Dirichlet?
What
You
is
like,
Dirichlet?
Wait, do you say like
Yeah, what is
rationals are dense in irrationals and then you use less than n? That's so halfway.
That's like one.
You gotta break up the into
Oh,
one
Oh.
and do a pigeon more.
Yeah. So
That's kind
can-
of
It's called Dirichlet's
So to
lemma.
review the
Pigeonhole
proof-
principle applies
I-
to the proof.
so we can review the proof.
That's kind of crazy.
I guess you don't need the full version of the theorem because you can just the pigeonhole thing will be sufficient.
Punchline time.
Punchline.
So say R for
Going to
irrational.
R is for irrational.
Alpha.
We just
I-
let we
I
give this
is
man
like-
too much freedom.
Mister.
And the set of Mister.
Instead of Mister.
No, this is fractional part.
Yeah, the fact. Oh, that's the fractional
Wait.
part of Mister.
I hope that your choice of notation is not just trolling. It's actually unintentionally bad.
Yeah. Nah. Next you gotta make like the set of sun or something.
Okay, so ln k over y.
Pass. Oh, the curly brace is not a set. Oh my gosh, what is the hell?
Oh, yeah.
Wow, he's really.
No, that's the actual notation.
Yeah.
Hey, it looks like
Set. It looks like, what is the difference between a set and a...
No, it's just what you write inside.
Fractional.
Alright.
Oh, I mean, it could be, but it could be the set
So
of
mixed
the
up.
number MR.
I feel like it's not necessarily standard notation.
So the fractional part is meant to be dense in the reals.
Dense.
Dense. I'm getting confused.
Dense
This is
in
like
I
new
am
analysis.
because if it's dense in the reals, you can make it in between any two of these numbers.
Uh-huh.
The hell is going on?
Hold on. Wait, is M an integer?
M is meant to be.
Yeah, M is meant to be.
It's positive.
Yeah.
But how do you know?
So you get complete freedom over m and n.
So M is just like it's running through all the integers. What's going on with M here?
So is just complete free choice of m and n.
So at the moment it's just all M and all N.
No, why is the non so?
Oh, but the thing-
Game's so rusty.
So the thing is that if the fractional parts work,
Like when you say it's dense, like you mean like as M varies or
the
as
gun can
oh yeah, it's m varies, yeah.
Wait, how is it even dense?
so it's the set of fractional parts. Let's do it. Let's do the curly braces. Just
Oh my god.
and jump out the window.
What is that?
So the set of fractional parts as m varies is dense in.
I can't believe we went down this path. It can't ever like
And so the reason it solves the problem is because when you make m large enough, then you can make n. You can adjust n to make it fit between these numbers.
The
What?
human
How is it dense? I swear it's not dense.
the human history of 300 years
Wait,
of
so
fake souls, and he comes in and
irrational
nests
number less than one,
curly
right?
braces like this.
Yeah,
And you take
The
multiples
audacity.
of it.
but the fractional part means it's always between 0 and 1.
But how do you show that's dense? It's a little bit.
Yes, that is the
What do you mean it's
Dirichlet.
always between
Oh,
zero?
that's
Wait, what do you mean it's always between? What's between? Wait.
Wait, what's the statement of the Dirichlet?
So for
Like, I'm
all
missing.
integers m, log on lat times m is less than 1, is that what you're saying? And it's dense.
Also, just this is less than 1, and also when you take the fractional part of m.
irrational.
When you take fractional part of
When you take
Oh.
irrational.
Well, I never knew that. Is that true?
Wait, do we?
Is
Wait,
that
what?
actually
Can we know what the statement of
So,
the
here's an
Dirichlet
example.
is?
No, I feel like this is weaker than Dirichlet.
Yeah, this is weaker.
The denseness has to be.
So here's an
also-
example.
The actual closeness. Yeah, the closeness can be related to the
So,
denominator.
An example is when you look at the fractional parts of multiples of pi, you can get it between any two real numbers between 0 and 1.
Oh, what?
So let's say if I want,
Wait, is that the Dirichlet theorem?
so that's a weaker version.
Well, what's the actual statement?
Well, you touch my
It's like
So
you can get it within.
if you want
the-
this,
Yeah, you can do it, but you
So you
can
can-
also even tell how close you can get it.
and let's see the actual theorem, Io-Bentheim
Like,
approximation.
Is it that?
Wait, you love the Dirichlet?
yes.
So this
I'm
was
going on Wikipedia in the exam.
have a little scroll.
so was
This is a little scroll.
so this was in the
Oh yeah, that's the thing. X minus Q.
Yeah, it's less than
One of
oh wait, this is a little
1 q squared.
slightly different form. Oh no, one of them was for transcendental numbers. And I think transcendental numbers are something. There's something else about them.
Or is it 1 over?
One. Oh.
Wait, can we see a proof for this?
Where's the
Proof is kind of.
He's given this intermediate talk in camp like
Oh.
4 times. You remember that?
Yeah.
He's the one who's proving that.
oh yeah,
How do you prove it?
It's a pigeon. It's a Dirichlet.
Oh, actually, I remember. I remember how.
Oh, and I remember.
I had to prove for like 5 times as well.
yep. So he's the full glory of theorem.
Wow.
So I think you could rewrite it as the fractional part of QA. If you times both sides by Q, the fractional part of QA, Q alpha.
And then you like,
fractional part of Q alpha is less than 1 over Q.
and then it can't stay in one.
9 kills and 1 dead.
Wait, it can't
So-
infinite loop because that.
Does that mean it's dense? Like.
Why is it?
Does that mean?
Why did it go to this screen?
Yeah, actually can't infinite
when the
loop because that's how.
Is this the wrong whiteboard?
Wait, but how do you know it's like? How do you know you can fit it between? Like, if it, you know it's less, but how do you know like? You can fit it
Okay, so you see the proof. So the pigeonhole proof. So let's say we have R 2R.
R for irrational.
So now we're going to divide the interval from 0 to 1. 1. So now we divide into intervals.
Batman lemma.
So example, let's say we're using it. Let's say you have Q equals 7.
Yeah.
So 1 over 7. Oh no, we don't.
Q equals 8. Quick.
Okay, sure.
Wait, did he say 8 over 7?
That's the one. Okay,
He crossed it out.
so now R2 over R. But now we can use the fact. So now all the numbers will go into these buckets.
Yes.
But now what happens when there's two numbers in the same bucket?
that difference is less than.
He wants to
That's
end
fine,
the sequence of questions.
That
By
difference
making
is
the-
less than what you put.
But the problem is you have to make sure they're in the right order.
Oh.
So it's a slight complication. So if m is less than n, 0 is less than fractional part of mr less than nr, and the difference. So if this is true, then n minus m. So when you do n minus m, you get the difference.
Oh. Oh yeah.
Yeah.
Fair enough.
but you just have to make sure they go in the right order. So, for example, maybe one complication could be what happens if the numbers in this thing go down. For example, if this was R, this was 2R, this was 3R. So that's not ideal, but this is a fix, which is you can just consider. So if m was, let's say m is less than n, but now if m is less than n, but now the fractional part's going in the wrong order. So if now they are out of order, so then you can still, because now n minus m it's going to be equal to I think it's a 1. It's going to be 1 minus.
Yeah. Because this was a negative of the fractional part of that.
Yeah.
What the hell?
So n minus m times r will be 1 minus mr minus nr. But now you can times n and m by something, because now it's going to be somewhere here. So the fractional part of the number will be somewhere here.
Yeah.
But when you take multiples of this, it's going to go this direction. But eventually you can get it down back to here.
What? No. 1 minus that, it would be in this interval, wouldn't it? Because that's between 1 on 7 and 2 on 7.
Wait, let's do an example. Yeah. Okay, so let's say this was 6. Let's say 6R was here and 9R was here.
Yeah.
You want photographic memory
then-
now then?
3R will be, and 3R is somewhere here.
Wait, no. Oh,
What?
oh the difference. Okay.
Yeah.
But now, if you double it, 6R will be somewhere here maybe. Then 9R.
That's
Wait, hold on.
Okay, so okay, wait. Let's use different numbers. Okay, let's do some more random numbers. 11R and 17R.
Irrational damage.
Okay, so 11R is here, 17R is here. So now 6R will be here.
What's
Then
over?
12R will be. So the gaps here must be the same.
Yeah.
What the hell?
So this is 18R, 24R.
Oh, right. Like the gaps don't exceed 1 over 7.
So then eventually something here will be between 0 and 1.
So you're proving Dirichlet's thing.
Yeah, but although I'm not sure if this is the standard proof, but it's kind of this is the proof I had in mind, which might not be the Wikipedia proof.
Aww. Wait, how does this show anything? Hold on.
Okay, so now it means you can get the fractional part no matter what case you're in. You can always get the fractional part in here.
Okay.
But now you just take multiples again. Now you go. You just take multiples. Now you can get in any region.
Okay.
So they're within 1 on Q.
Yeah. So
What is...
now you can get an NR here. So then 2 NRs. Or it doesn't have to be in the same region, but you can never skip a region.
Yeah.
So you never skip a region, which means you'll always be in. Every region is accessible.
Yes.
Oh,
So
so
now
if you make it 7 bigger, so then you can like switch it.
A lot more.
So now, let's say we are between any two real numbers. We want to get the fractional part between any two real numbers. So let's say P. Oh no.
You take a big enough rational such that
Wait, isn't
you
R
have
irrational?
a thing.
So X is less than.
R
I already used X. Okay.
R
Running out of letters. No, wait, it's not good. U less than V. So, say we want between any two real numbers. But now we choose rational numbers here.
Yeah.
With the same denominator.
Yeah. So
That always
something like so S is rational and T is rational.
You take that P is less than B minus C.
Alright.
It's all just... Oh wait. It's all you need.
Oh, the same denominator.
Oh.
Yeah, so it's something like this. Oh, S plus T plus 1. S plus 1 over K.
Okay. Yeah.
So now we can get it. So between any two U and V, so no matter, even if these are irrational or rational, it doesn't matter because you can always find some number k to make it work. And now you apply this again.
Wait, so does NR have to be irrational? Or can it be rational as well?
I is irrational.
Yeah.
So R is irrational and n is an integer.
Yeah.
Oh.
Does R have to be irrational?
Yeah.
Actually,
If
yeah,
R
actually,
isn't
yeah.
irrational, then
Actually, yeah, you only have to choose. Alright.
Yeah, because R wasn't irrational, then the fractional parts will repeat.
Yeah, it would. Yeah. Okay.
Irrational.
Okay.
What the hell?
And then now we found out being manifold.
So-
Oh, wait, hold on.
So
Go back to the
so
no, we're done then.
so it
one
means
in between those.
the fractional parts are
No,
dense
it
in the
doesn't matter
reals.
what we want.
Yeah.
It's just the fact that it's dense.
Oh, wait, yeah.
So
Yeah.
now you go back to the original one.
Yeah, you
So we can get whatever we
Yeah.
want.
So this fractional part can be anything,
Yes.
and when you vary n, it means
Wait,
basically the number can be anything.
Wait, this wasn't even that hard.
Yeah, exactly.
Ah,
Okay.
okay, never mind. I get what Leonardo was talking about. It wasn't that hard.
Yeah, I think I understand how to.
So what does this?
My own
So
version
since
of this.
k can be, so since k can be any,
K can be any.
so k can be any positive integer. So yeah.
That I think that's faster than the other one.
That's so much faster.
So I guess it's kind of, so if you know the theory, it's a quick solution. So it makes the problem look kind of boring when you do it like this. But I saw Michael on the Overleaf doing some unusual, some very interesting stuff. Yeah, I saw some powers 2 to the power of L somewhere.
Oh, yeah,
That's the main. Yeah.
Jewish laser.
Or was that was that
The element.
people actually found this?
I feel like
Most people found that
saw
solution.
something.
You get two in
You
the
get
set,
2 and
then you
3
get
and
in
like,
the
or like,
set,
yeah,
and then
yeah.
you generate everything.
Yeah.
Okay.
Hey George,
Is everyone happy?
Hold on. So,
Michael.
minus. Oh, I thought they were understand that. So you're saying you got the m times the fractional log any number between 0 and 1, basically.
Yeah.
And
So when you vary n, so varying n allows getting every. Oh, but you also need. I think you might need this to be sufficiently large because you want n. I guess since n can't be n has to be positive, which means you want. I guess you want to choose a large m.
oh, okay. So you want to be able to do it with m sufficiently large. Wait.
So I guess it's slightly stronger. I guess you want sufficiently large m that satisfies the dense condition.
Okay. So
It's
the,
not even actually that hard. Actually, yeah.
I feel like I have my.
okay,
own
so the main thing is that
original-
m times an irrational number,
Yeah.
as you vary m,
Yeah.
can get sort of
Every-
as close as you want to any fraction. Like
Yeah.
some number with like any fractional part. It's just that the integer part could be huge.
Wait, I feel like you just go like.
And then and then use n to kill the excess of the
Yeah,
integer
it's
part.
excess, yeah.
But I feel like you could say like you travel a
That's a
certain
double, yeah.
interval, but then when you reach the
I think
end of the
main
interval, it wraps
intuitive
around, and then there has to be one of them that's at most half of the original interval. So you can keep partitioning by 2 to get arbitrary
I
precision.
think as soon as I saw this line, I kind of instantly knew that Jewish K would probably work.
I literally have this line.
Bro, this is
You go to the logs bit.
So that's like saying the Dirichlet thing. I guess it's
So it means-
it's in the syllabus.
If it was intuitive, if x and y are not powers of something else,
That
then
came out as an ASC.
you can make x to the m over y to the n anything you want.
But see, like I guess that's what gives you like if Q5 takes a long time, that might will give you the chance to do Q5.
I think
But the people who you said that got all the questions, did they do this for Q4 or did they or unspecified?
Leonardo did this.
Chris and Jan and Will.
Chris did the QS2. I don't know about Will and Young.
I don't know.
Shishi also tried doing the 2 thing, but he messed up a bit. he did like some kind of weird logic where like if 2 does exist, then 3 exists. But if like 2 doesn't exist, then 3 must exist. But then if 3 exists, then 2 then exists. Or something like that. But like it doesn't work.
Some suspicious logic.
Okay, so here you prove that log is the fraction of the logs is irrational.
Yeah, that's a main
Yeah.
part as well.
So I think the idea. So we see is if x and y are not powered with something else, then you can basically vary it as much as you can. It's kind of intuitive to see if you tweak m, make m a bit large, n a bit large, or m small, n small. You can pretty much get it between any two numbers.
It's kind of clever. That's nice.
One shot by a lemon. By a bad problem.
Okay, that's right. I thought this would be the most common solution, but
I literally got up in here and I didn't know the original theorem, so I was like, what the hell do I do? Oh, wow. End of a path. Do Michael. Turn to Michael.
see that's the end of question 4.